Hello viewers, my name is Damilari. In this lesson, we'll be looking at the topic water. What is water? Water is an important natural resource that gives life. It is the most abundant in plants and animals as well as the world around us. In our body as human, we have 70% of water, and for the heads, then we have 80% of water on heads. And the sources of water include rain, well, river, spring, etc. And the purest source is rain. The types of water, we have natural and we have treated water. When we talk of natural water, that's the water that we get directly from God, like through the rain, when rain falls, or through the spring water, well, river, and sea water. But treated water is the one that is prepared for special purposes, like the distilled water, the pipe-borne water, and the chlorinated water. For the distilled water, it is used in the laboratory for preparing reagents. That's the chemicals you want to use for your tests or analysis. So, and that is another word for analytical work. It is also used in the preparation of drugs, car batteries, and certain industrial purposes. Water pollution. Water that is unfit for the purpose for which it was intended is said to be a polluted water. And what are the effects of water pollution? It threatens aquatic life, meaning any living organism in water will be affected when the water is polluted, and it can change the body of the water. It makes it unsightly, like you will not like to see it, just like lagoon. And it gives foul smelling. The smell that comes from polluted water is bad. It affects health through aquatic animals. Maybe animal that is in the polluted water, if one should hit that animal, one will also be affected indirectly. So what are the uses of water? We have domestic use, talking about drinking, washing, fire control. We can also use water for making drugs, for paints. So these are the uses of water. Then another aspect of water we'll be looking at is what I call structure of water. When I say structure of water, because water is a molecular substance, molecular from the word molecule, so it is regarded as an oxide of hydrogen. That means it has oxygen and it has hydrogen, so oxide of hydrogen. And the structure, seeing H in two places and O at the center, so at the angle of 105 degree, so which means you can call water L shape. That means something like L or V or angular shape. So we have different types of water based on relationship with soap. That means when you add soap to water, so the way the water reacts, tells us the type of water it is. Like we have hard water which does not lather readily with soap. That means it will not foam. So this is due to the presence of certain salts. We call them calcium sulfate, magnesium sulfate, calcium hydrogen carbonate, just say CMC. So these are the salts that makes water hard, and it can come from the soil. So from the soil, it just flows along with the water, making the water become hard. And this hardness can be temporary or permanent. For a temporary hardness, it is this calcium hydrogen carbonate that makes salts or water become temporarily hard. So for calcium hydrogen carbonate or magnesium hydrogen carbonate, so they make water become temporarily hard. So which means it can be decomposed when we heat it. That means the remedy to that is by boiling. When you boil, you know from calcium hydrogen carbonate it can break into calcium carbonate and water. So another way of removing this temporary hardness is by adding slake lime. Slake lime is calcium hydroxide. So it means for temporary hardness, you can boil and you can as well use a chemical which is slake lime. You can remember this using the idea of a marker that is erasable. You can use a normal duster or water to clean the erasable marker, or if it is chemical you have, it will still erase it. So, but when it comes to permanence, it's only chemical alone that can be used to take away permanent hardness. But boiling can't do that of permanence. So, still looking at temporary hardness. So, what method can we use to remember the chemicals or the salts that makes water permanently hard? You can take the three letters C from calcium sulfate, M from magnesium sulfate, then join it with the P, permanent. So meaning camp. Once remember camp, it means calcium sulfate, magnesium sulfate makes the water become permanently hard. That's camp. But only calcium hydrogen carbonate or magnesium hydrogen carbonate, so that one will make water temporarily hard. As I said, it's by boiling you can remove temporary hardness or you had slate line. And what will be the effect? While boiling that kind of water, it will affect the kettle you are using. That's what they call fouring of kettle. You will see something like whitish substance, so which is limestone. So you can also see stalagmites and stalactites. So these are also the compounds that will be coming out from the hard water. So looking at permanent hardness, like I said, is only chemical we can use to remove this permanent hardness, and that's through distillation, addition of washing soda, addition of caustic soda, permutate. So these are different ways of removing permanent hardness. So the distillation, that's taking a round bottom flask where it will be heated and allowed to pass through Liebig condenser, so to make sure the permanent hardness is removed. Or you add washing soda, sodium carbonate. So this is a washing soda, so it helps to remove the hardness. Then caustic soda, sodium hydroxide, can also remove permanent hardness. Then the one we call permutate, that one is a complex substance of hydrated sodium aluminum trioxosilicates with a particular water of crystallization. So we call it sodium zeolite. So that's the permutate. So it's comes in form of ion exchange resin column, IERC. If you rearrange these letters of IERC, you can turn it to RICE. That's rise. So ion exchange resin column. So now another thing we'll be looking at is laboratory preparation of water. How do we prepare water in the laboratory? That means maybe I need distilled water. How will I prepare it? So it can be by oxidation of water. So it is prepared by condensing steam. That means you make sure your steam is produced. That's something like hot water. You condense it. That's through this Liebig condenser. Or you pass that water through ion exchange resin column. The one I say you can form from letter of RICE. So which is the permutate. So just pass your steam or water, just pass your water through ion exchange resin column. It will help you to prepare your distilled water. Now, how do we test for water? How will you know that this is water and not acid? Because water and acid look alike when you just see them inside the beaker. So the first thing is you get copper sulfate anhydrous, which is white. Add it to water, it becomes blue. That means it becomes hydrated copper sulfate. Or you get a cobalt 2 chloride. This cobalt 2 chloride is actually blue in color. So by the time you add water to it, it becomes pink. It means from anhydrous, which was blue, to hydrated, which should be pink. You can remember using the CO of the cobalt 2 chloride and the PI of the pink. So saying copy, just like copy. So that's for the test for water. Then we'll also be looking at municipal water. That means purification. How do we purify our water? The first thing is aeration. From the word aeroplane, anything that has to do with air is aeration. Aeration of untreated water. You get your untreated water, the water that is dirty, you aerate it by steering. You steer the water so that any volatile liquids such as iron 3 ion, hydrogen sulfide, carbon 4 oxide, odor, they will leave that water. So through aeration. So you can, these volatile gases I said will come out. You can use a mnemonic CHOI. That's choice to remember things that will be living. It means during aeration, choice will be removed. That means C for carbon 4 oxide, H for hydrogen sulfide, O for odor. The ICE, just it as ion. So iron 3 ion will be going out of that aerated water. So the next thing will be coagulation. After aeration, coagulation. You know, water that you are steering, some dirty things, particles will be moving along with it. So those particles moving along with it will later clump. They will clump together, and that's what we call coagulation. They will come together. So, and after coming together, they will later go down. Going down is what we call sedimentation. An easy method of remembering, that's coagulation, from the word coagulate, you can say come together, coagulate. Then sedimentation, you can say settle down, sedimentation, settle down, meaning that these coagulated impurities or dirty things in the water, they will later settle down. What caused this? Presence of alum. This alum always gather dirt, and that's potassium aluminium sulfate or sodium aluminium oxide. So this can be used to coagulate dirt in the water. You can also, then the next process is filtration. Filtration means you filter on a filter bed so that you can remove any impurities. So that is filtration, helping to remove any impurity in that water. Then after filtration, the next process will now be the chlorination, fluorination, iodination. That means when you talk of chlorination, it means the chlorine will help to kill any germs that is in the water, and that's why you see sometimes when you go to amusement park where we have this swimming pool, so the color of that swimming pool may look blue. Why is it blue? Presence of chlorine. So that chlorine is to kill germs. So chlorination. So we help to kill any germs that is still in the water. That's after filtration. Then iodination. That means adding iodine. Why this iodine? Iodine can help to prevent goiter. That's big neck. And also as a food supplement. So while taking the water, fluorination is also very important for fluorine. This one will help to prevent tooth decay so that the tooth will not be affected. So, and that's why fluorination is important in water purification. Then finally, storage in reservoir and distribution of treated water through underground pipes for use. It means that water you have already purified, you store it in a big reservoir, then distribute it to wherever it is needed. So either through underground pipe, that's the pipe-borne water. So that's how to purify water. So we'll be moving to the second stage of water, and the second stage is knowing the advantages of hard water. What are the advantages of hard water? You can just use this mnemonic CTLS, just like Cutlass CTLS. C means calcium. It means hard water has, from just like that calcium hydrogen carbonate, it has calcium which will help the teeth, help the bone. Letter T is taste. It gives better taste. Hard water has a particular taste compared to soft water. Soft water, remember that one does not form lather with soap when you use soap to with the water. So, and that one is tasteless, but hard water has better taste. Then letter L, that is lead pipe. So this supplied in lead pipe, that means that hard water, when it is supplied in lead pipe, it will not dissolve. So the lead pipe, the lead will not dissolve into in the hard water compared to soft water. So that's for the L. Then S, snail. It means it helps snail shell. It produces shell. Remember that snails, they are calcareous. That means they have calcium. So the calcium is also coming from hard water. So it helps the shell of snail and crabs. So that is the advantage of water. Then we also have physical properties of water. What are the physical properties of water? If you want to remember, just take B, C, D, F, just like reading A, B, C, D. So the B means the boiling point of water is 100 and the freezing point or ice point is 0. So that's number one chemical property. Then letter C, water is colorless. It is colorless, odorless, and tasteless. Then letter D, density. Density of water is 1 gram per cm cube. Then the letter F, that's the intermolecular force. So there is enough intermolecular force in water, or you call it hydrogen bond from the formula of H2O. So it has hydrogen bond. So these are the physical properties of water, and that's why, because of the hydrogen bond in water, that's why it's denser than ice. It's denser than ice. That means coming down, and even a canal. So it's denser than ice. Now let's move to the chemical properties of water. Looking at water, it's having both acidic and alkaline nature, meaning that water can add with potassium to form a base, an alkaline. So like K plus water to give us KOH, and hydrogen gas will be liberated, just as a metal in acid will liberate hydrogen gas. So water again can also add to a non-metal like chlorine, and it will give us acid. So like water and Cl will give us HCl, and then the hypochloric acid. So these are the two important chemical properties. Then the third one here, water can also now take the oxide of the metal. Instead of only the metal, it can take the oxide of the metal and still give us another base or alkaline. So alkalis, which does not need hydrogen gas again. Then that same water can still take a non-metallic oxide and give us acid without any other products. So these are the chemical properties of water. Now we want to move to solution. Why are we looking at solution? Because water can form solution. How? Because solvent is liquid. Talking about water, for example, then solute is our salt, our sugar, or any substance that can be dissolved by that solvent. So when solvent and solute come together, we have solution, and the solution can be a true solution, or it should be a suspension, or it should be a colloid, which is a false solution. So that's FC. You can say football club, meaning that false solution is a colloid, FC. Now let's start with the first solution. The first solution we are looking at is the true solution. So we call it mixture, true. And why is it a true solution? Because it's an homogeneous mixture. When we say something is homogeneous, that means they blend together, they agree, they come together as one. Just like when salt and water mix together, you will see that you will not be able to see the salt again, to just dissolve completely in that water. So it means we call it homogeneous. But when you take sand and water, they will not completely mix together. So that one is not homogeneous. So, but the one that will mix together completely is homogeneous solution. So meaning example of true solution is salt and water. And from there we'll be looking at water as a polar solvent. The water that mixed with the salts, so which we said makes a solution true. So it's because it's a polar solvent. It has a structure that is polar in nature, that positive and negative charges on different sides can make excellent solvents for electrovalent solutes. So meaning that the water can dissolve salts. Then we now have those ones that are non-polar. So those ones that are non-polar, they are like kerosene, all these organic solvents, petrol, benzene, turpentine. So most of these may not dissolve what water is dissolving, so and vice versa. So if water is dissolving the electrovalents, so water majorly dissolve electrovalent, as you can see it here, electrovalent. So water dissolves them, so because it's a polar solvent. But the kerosene, petrol, benzene, they are non-polar, so they won't dissolve what the water is dissolving. So they won't dissolve it directly, so but they will rather dissolve covalent bonds, covalent instead of electrovalent. So they will dissolve covalent bonds. So covalent compounds, so they will dissolve covalent compound. And take note of these types of solution. We have what we call aqueous solution and chemical solution. What is aqueous solution? Aqueous solution is any solution that has water solvent in it. So anything that has water is an aqueous solution. For example, sodium chloride appears solid, but once you add water to it, it becomes aqueous. Now, chemical solution. When you take your solute can be magnesium, mix water solvents like HCl solvents. So by the time you join these two together, they will actually come together, but there will still be a chemical reaction. In what way? The magnesium will liberate hydrogen gas from the HCl. So that's a chemical reaction accompanying the solution. And the next thing we'll be looking at is suspension. Suspension is now heterogeneous. If the true solution is homogeneous, but suspension is heterogeneous. That means there will still be undissolved particles. Undissolved. So homogeneous, there will be no undissolved, but suspension, there will be undissolved particles in the medium. So when you mix it together, you will see undissolved particles. And a good example of suspension is harmattan. During harmattan season, you will see suspension. Like when you first wake up in the morning, you see something like whitish things, as if they sprinkle powder into the hair. So it means it's suspending, it's not mixing with the hair, so like dust in air. So another aspect of solution, which is the third one, is colloid. Colloid is a false solution, and this is an intermediate between the true solution and the suspension. So it means I can put letter C in the middle of T and C and call it TCS, like tax, TCS, T true, C colloid, S suspension. Meaning that colloid is an intermediate between true and suspension. So now looking at this colloid as a solution, a false solution, and there are different examples of colloids that we can list. So what are the different colloids? Just use first preach message. First preach message. That means someone that has a message to preach. So he should first preach the message. So the letter F for first means fog. Fog is one of the precipitates that comes from the atmosphere. The way we have rain, the way we have snow, the way we have all these different kinds of precipitate coming from the atmosphere. So that's how we also have fog. So it's always a colloidal form, so it will not fully mix. So that's F for fog, FOG. Then another one we have, from the word first preach message, first preach. So we have seen the letter F, meaning the letter P. P for the preach. So that is protoplasm. Protoplasm is a colloid. Looking at protoplasm, is made up of cytoplasm and the nucleus, just like all these animal cells. You see that they look slippery. So something slippery is colloidal. So that's why protoplasm is a colloid. So first preach message. From message, letter M. M is milk. Milk is colloidal because of the thickness or viscosity. So milk is colloidal. Then E, letter E is emotion, just like emotion paint. Emotion paint, when you touch it, is very thick, or you call it viscous. So emotion is colloidal. Then E from the spelling of message. Apart from M, which is milk, E emotion. Okay, the next letter will be S. S is smoke. Have you seen thick smoke? Smoke that is very thick, where there is huge fire. So that thick smoke is also can be taken as colloidal. Then the next letter S is starch. Starch. When you take starch with hot water, you know how it is thick, just like pap. So this starch is said to be colloidal. Then the next letter is A. A is said to be albumen. Albumen. Albumen is found in egg, the white of an egg, but before they boil it, so they the one that looks like water there, that is colorless, that is albumen. So it looks thick or viscous, so it is also colloidal. Then the next letter is G. We see G as glue. When you see glue, all the super glue and the likes, they also look like viscous, thick, so they are also colloidal. So from the mnemonics first preach message, you remember different colloids we have. Next thing we'll be looking at is that how can we now differentiate true solutions from suspensions and colloids? For true solutions, their own particles, they are in solution, they will mix together for true solution, and that is common in ionic, or you say electrovalence. But for suspensions, they have larger particles, that's why they are suspending. Larger particles, they are suspending. It's just like something that is too big, bigger than the container where you want to put it. It means that thing will not be able to enter that container. Some of them will suspend. So it means suspension has larger particles. So, and that's why they will want to settle down or hang. So, but for true solution, their own particles are not large, they are small, so they mix form solution like ionic. While for colloid, their own particles is too small to the point that they form viscous substance. Another difference is that for true solution, they will not settle. I said suspension, they will settle. That means they will just relax. It's like when something is trying to force itself into a container and is unable to force itself, it will just relax, like it will give up and just remain on top of that container. So you can even use the letter S and S. Suspension, they settle down. But for the true solution, they will not settle down, they will mix together with the water, and that's why we call it true solution. Just like a true child of God in the place in church, you see how they will not just settle down, they will be up and doing, up and doing. So the true solution will not settle. But suspension, just like maybe someone that is suspended in church, that he should just be suspended. It means that person, they can say, okay, go and settle down, go and sit somewhere. That means don't do anything. So suspension will settle down, but true solution will not settle. Likewise, colloid also will not settle. It means suspension and colloidal, they somehow have something related. So it means both of them will not settle. You can even use letter S. I mean, both of them will they will settle down. So they will settle. For suspension, we said it will settle down because it will try to enter but unable. So it has to settle. So why colloidal will not settle? So it will not settle. So because it's thick. So something that is thick, so it will not settle. It means we can relate true solution with colloid. So T and C, both of them will they will not settle. Now the next difference is for true solution, the solutes can diffuse through semi-permeable membrane. I repeat, for true solution, the solutes can diffuse through semi-permeable membrane. That's what we call dialysis. If you look at dialysis in the hospital, maybe someone that the kidney is having problem. So when the person goes to the hospital, there is a dialysis machine that they will use to help to permeate the salt in the person's body, salt and water, which is the urine. So it will be able to permeate out of the person's body. So through is a semi-permeable membrane, something that looks like cellophane or bladder. That's the pig bladder. So they are good permeable membrane. So once again, in true solution, where we have salt and water that is homogeneous, the salts can permeate through what we call semi-permeable membrane. That's during dialysis. So dialysis, once again, is when solute can diffuse through semi-permeable membrane. But when it comes to colloidal, the colloid, those ones cannot dialyze, it cannot permeate. Imagine thick substance like pap or milk. So trying to permeate through, it will be difficult for thick substance to permeate. So because they are too thick. So just like heaven also being a narrow way, so it will be difficult for someone that is too big in terms of with load of sin. So it will be difficult to penetrate. So that's how colloid is. So it can't dialyze. Then another point, for true solution, it will not scatter light ray. That means no Tyndall effect. No Tyndall effect. That means when you have your true solution, salt and water, if you on touch light, that light as it's coming, it will not scatter the light ray. So it means it will allow the light to pass. So that is just like, as I said, true solution is like a true Christian. That means he will allow the light of the word of God to pass through, penetrate his life. So no Tyndall effects. He will not, there is no Tyndall effect. That means no throwing away of the light, no throwing away of the truth. So that's no Tyndall effect in true solution. But when it comes to colloid has Tyndall effect. It will scatter the light. So why? Because colloid is like someone that is too heavy, that is too thick. That means as the light of the word of God is coming, it will just be scattering it, because the life is full of sin, it will just be pushing it away. So that is the difference we have. Then another thing we'll be looking at is the okay, we want to look at suspension. When you hear the word suspension, what does that mean? For suspension, that's substances that are large enough, they are visible, they are heavy to sediment. So anything that is heavy to sediment, that means it's difficult for it to come down. Something that is difficult to come down will suspend. This suspension is just like maybe someone that is praying and the person's leg is not touching the ground again. You see, this person is suspending, like during rapture. So at the time of rapture, we suspend in air. So the same way, when your particle is suspending in air, it means it's not able to sediment. So it's large enough. So, but colloid, they will not settle out. Now, let's move to dispersion. This word dispersion is like scattering, disperse. When something is being dispersed, like scattered. So we'll look at solid that is dispersing in gas, we call it smoke. Solid, see it as your wood, like a firewood is solid. So disperse in gas, when you burn your wood, it will turn to gas. That means the smoke coming out. So that's solid in gas is smoke. Then liquid in gas is fog. Liquid, see it as rain. Gas, the air. So the rain and the air, we can see it as fog. Gas in liquid, see it as foam or ladder. The gas, that means when foam from the soap is going up, that's gas. That means a form of air. Then the liquid, the water you are using to form the soap, so is the liquid. So gas and liquid is foam. Then liquid in liquid is emulsion. Just like if you want emulsion paint is actually liquid. When you also mix water again, that's liquid. So liquid is emulsion. Then solid in liquid, we call it salts or gel. Even from the name salt, solid liquid, salt, solid liquid. So it's solid in liquid is salts. Then gel, looking at gel is like thick substance like solid and at the same time like liquid. The gel women use for their hair. So it is solid in liquid. So these are the different dispersion. Then finally, we'll look at what we call dissolution. Dissolution means you dissolve your solutes in solvents. You dissolve your solutes in solvent, like sodium chloride now, your salt, dissolve it in water, it will dissolve. Copper sulfate, dissolve it in water, it will dissolve. Sugar, it will dissolve in water. But when it comes to iodine, naphthalene, you will need ethanol because iodine will not dissolve in water, just like phenolphthalein. Phenolphthalein will also not dissolve in water except you use ethanol. So you need ethanol for iodine, naphthalene, phenolphthalein. So that's why you can just use pine, just like Pinus caribbean. So P-I-N-E, P, phenolphthalein, I, iodine, N, naphthalene, then E, ethanol. Use ethanol to dissolve all of them. Then grease. For grease, you need petrol. You know grease that they use for this grinding machine. So the petrol they will use for the grinding machine, you can still mix it with the grease if you want to dissolve it, or you use ammonia. So just say palm. So that means the palm means petrol and ammonia. Then groove, just say palm groove, petrol, ammonia for grease. Also for fat or oil, you need kerosene. Just a free kick, F and K, free kick. F is the fat, K is the kerosene. So you need kerosene to dissolve fats. Then for sulfur, you need carbon sulfide. You know that sulfur will not dissolve in water except is in carbon sulfide. So just say SCOS, SCS, SCOS. So sulfur in carbon sulfide. Then rubber is in benzene. From the name rubber, the bar is the benzene. So for rubber, you need benzene to dissolve it. Paint is in turpentine. From the word paint, pentine. So it's in turpentine. Then coffee or tea, you use borax solution. Borax, so you can use cobra to remember co from the coffee, then bra from the borax, cobra, coffee in borax. Then quicklime, none. So none. So then emulsion, detergent solution and water. So this is where we stop for today. Thanks for listening.